Welcome back, class. So today our goal is to talk about the basics of doing this method u-substitution to solve definite integrals instead of what we've been doing so far, which is indefinite integrals. And so far, remember that what we've been doing is we've been finding antiderivatives. So in this last horrible example we started with the function x to the fifth times the square root of 1 plus x squared. And at the end of the day, we found this function. And believe it or not, if you take the derivative of this function and simplify the answer, it turns out to be that. That's what we've been doing. And everything we've done this week with u-substitution has been that. But now we're swapping that perspective and we're thinking about definite integrals instead. And remember, the way you know this is a definite integral is that there are these numbers here labeling the integral. And remember, this thing is an area. So in particular, the answer here is a number. And remember, it's technically a signed area, so I'll put that caveat here, by which I, again, just mean we're counting the area below the x-axis as negative. But if you want, you can go ahead and visualize this, because here's a graph. And so I've shown you a graph here of this function, minus cosine squared of x times sine of x. And I've shaded the area there between 3 pi over 2 and 2 pi. Okay. So I want to think about what's happening when we do u-substitution here. So I have to decide on what my u is going to be. And I notice this cosine is sitting inside a squared. So I'm going to let u here be cosine of x. So then du is minus sine of x. And so that is going to be my translation device. And so this is going to become, okay, so this cosine squared, that's just a u squared. And then that minus sign together with that sign, that gives me a, no pun intended, minus sign. And so this is u squared du. Okay, and so far everything I've done is exactly the same as what I had done with indefinite integrals. The only thing that's different is now I have these limits floating around. And I want to remind you that these limits are very definitely something that's framed in terms of the variable x. Namely, these limits are telling me where on the graph of minus cosine squared of x times sine of x to find the region whose area I'm finding. Namely, it's telling me to look between 3 pi over 2 and 2 pi. So I have to translate x equals 3 pi over 2 and x equals 2 pi into the language of u. And the way I'm going to do that is with this relationship here. So I'm going to say, okay, if x equals 3 pi over 2, then u equals the cosine of 3 pi over 2, and the cosine of 3 pi over 2 is 0. And likewise, if x equals 2 pi, then u is the cosine of 2 pi, which is 1. So to repeat, all I did here was to translate the number x equals 3 pi over 2 from x language to u language by using this identity here. So I got x equals 3 pi over 2, that corresponds to u equals 0. And likewise, x equals 2 pi, I translate to u language and it becomes u equals 1. So this integral here becomes the integral from u equals 0 to u equals 1. Okay, and so here's the important fact, and this is the big takeaway. When you do definite integrals, you also have to translate the limits. Okay, now I want to take a moment here to appreciate that something kind of magical just happened. Namely, we translated this integral of some ugly thing involving trig functions to this integral of something involving just the parabola x squared. And we're saying here that these two things are the same. So what I'm going to show you now is I'm going to show you a graph with the area corresponding to this integral shaded, which is the same one I did before, and then it's also going to have the area corresponding to this integral shaded. And what we're claiming here is that these two areas are actually equal. So you see here over in light gray, on the right of the graph, we have the graph of minus cosine squared sine of x from 3 pi over 2 to 2 pi. That's shaded in light gray. And then over in dark gray, we have exactly the area between 0 and 1. That vertical line is at x equals 1, which is not labeled. But the vertical line is at x equals 1. So that's the area between 0 and 1 under just the graph of y equals u squared. And so what's not at all clear is that if you sort of squish the area on the right into this sort of parabola form, it's exactly the same as that of the area on the left. But it has the bonus that I didn't previously know how to calculate the light gray area, but I definitely know how to calculate the dark gray area. So what I'm going to do when I'm doing a u-substitution for a definite integral is I'm going to translate it, and then I'm going to do the new definite integral. So I'm going to do this integral here, which is going to be u cubed over 3 by the power rule. Remember, I have to plug in my values here. And so this is going to be 1/3 minus 0, which is 1/3. Okay, and so mathematically what I'm saying is the area of the light gray region and the dark gray region are both 1/3, and so that tells me the answer to my question. All right, I'm going to do more examples next time, but I think understanding this picture really helps us understand the process and appreciate that we're doing something pretty cool here. All right, I'm going to drop off for now here, and next video I'll give you a bunch more examples of calculating things with u-substitution. But until next time, be well.